Right, I'm going to take you through a few equilibrium problems to hopefully help you out with any issues you're having. So probably pause the video now, have a go at the one that's on the screen if you haven't already, and then I'll take you through it. So we've got our initial moles of both the H2 and the carbon monoxide, and the other key thing we know is how much we've got left of the hydrogen once it reaches equilibrium. So the only thing we can do to begin with is work out what the change in moles of the hydrogen must have been, and it's just the difference between the initial and the equilibrium moles. So 0.5 minus 0.1 leaves you with what means we must have used 0.4 moles of the hydrogen. Next step is we can use that to figure out how much of the CO we must have used. We need to use the ratio of the reaction, so it's a 2-to-1 reaction. So if we've used 0.4 of that, we use 0.2 of that, so it's half of the CO. And then we can get the equilibrium moles for the carbon monoxide by looking at how much must be left after it's used, and it's just the difference between those two. So we've got 0.3 moles. Next step is to figure out how much methanol we must have made. Now, if we've used 0.2 moles of carbon monoxide, that should increase our moles of methanol by 0.2 as well, because they're 1-to-1 in their ratio. And since we started at 0, we'll have 0.2 moles left at equilibrium. So your equilibrium moles should be 0.1, 0.3, and 0.2. Let's go on to the next problem. Again, if you pause it first and then have a go at it, and then we'll have a look. So, same reaction, hydrogen, carbon monoxide making methanol. This time just different starting amounts of our hydrogen and carbon monoxide. So we've got 1.2 of hydrogen, 2.0 of carbon monoxide. We're left with 1.8 of carbon monoxide at the end. So again, work out how much has been used. So we've used 0.2 moles of carbon monoxide. Again, we use that 2-to-1 ratio, but we're going the other way this time. So instead of dividing by 2, we're going to times by 2. So 0.4 moles, again, of hydrogen have been used, and then find the difference to get 0.8 of our equilibrium moles down there. So we're nearly there. Again, carbon monoxide is 1-to-1 with your methanol. So the 0.2 moles we used of carbon monoxide will increase our moles of methanol by 0.2. And since we don't have any air to begin with, we'll end up with 0.2. So there are your equilibrium amounts in this one. So any problems with those, they're kind of your straightforward ones, then do contact either myself or Joe, or if you've got another chemistry teacher, you can contact them. Let's look at a couple of slightly trickier ones. So here's one, it's the Haber process. It's nitrogen plus hydrogen making ammonia. This time we have some products and reactants already there. So again, pause this and I'll have a quick go at it. Right, so same basic principle as before, just we're going to start on the right hand side this time. So we're starting with 10 of the ammonia and we're left with 9. So that means we must have used 1 mole. The amount of moles used is going to tell us how much of the nitrogen and hydrogen that we must have made. So if we've used minus 1 mole of ammonia, it's a 2-to-3 ratio with the hydrogen. So we're going to increase our moles of hydrogen by 1.5, and we're going to increase our moles of nitrogen by 0.5, because that fits then the ratio of the reaction, and the equilibrium moles down below are then going to be 1.5 for the hydrogen, and with the nitrogen we've already started with 10, so we need to do 10 plus the extra 0.5. So our equilibrium moles are 10.5, 1.5 and 9. Then a similar one next, same kind of idea. So again, pause it, have a go. So we've got 0.4 equilibrium of methanol. We have 2 moles of the SO2Cl2 as well. So what we need to do, we know that we must have began with, since we began with 0, we must have increased our moles of methanol by 0.4. Which, considering it's all 1 to 1, means that we must have lost 0.4 moles of the SO2Cl2, which means the difference there is 1.6. And it's all 1 to 1. We've started with no Cl2, so if that's gone up by 0.4, you'll have 0.4 of that one left. So, relatively straightforward one there as well. Okay, more of these later.